Hi folks, we're going to take a look at page 140, number 3. So here we've got, again, we're looking for some unknown coefficient to a polynomial. And they tell us that when I divide this polynomial by x minus 1, I get the same remainder as if I divide this polynomial by x plus 3. Okay, so here I notice that I'm dividing the polynomial in both cases by linear divisors. And the information I'm given only has to do with the remainder. So I should be thinking about using the remainder theorem instead of actually dividing out any polynomials. Okay, now they don't tell us what the remainder is, but they do tell us that the remainder when I divide by each of these is equal. Okay, so I can say that the remainder when I divide by x minus 1 has to be the same as the remainder when I divide by x plus 3. So why don't I just use the remainder theorem both times? And I know that those remainders have to be equal. So when I divide by x minus 1, the remainder is just given by p at 1. So the polynomial evaluated at 1, okay, is what gives me this remainder, and the polynomial evaluated at -3 is what gives me the second remainder. So all we have to do is just plug these numbers into the polynomial. So let's start with p at 1. So what do we have? We have 4 minus 3 plus b times 1 is b plus 6. Nice and easy. And now we'll stick in -3. So 4 times -3 cubed minus 3 times -3 squared plus b times -3 plus 6. Okay, so here we have 4 minus 3 is 1, plus 6 is 7, so we have b plus 7 on this side, and I think for the other side I'll get my trusty calculator out. Okay, so let's see what we have. We have 4 times -3 cubed minus 3 times, and I could do a lot of this in my head, but let's just use a calculator. Whoops. -3 squared, okay, and then plus 6, okay, -129. So here I'm left with -3b, and then here I've got minus 129. Okay, and now we've got a pretty easy equation to solve here. So what do we have? We'll bring the -3b to the other side, so 4b is equal to, and -129 minus 7 is going to be -136. Okay, and so now just divide by 4. I think this I can do in my head, so that'll be -13. So 4 goes in 3 times. I'm left with 16. 4 goes into 16 4 times, and there we go. B has to be equal to -34. Okay, so let's recap. In this question, I was looking for an unknown coefficient in a polynomial, and the information I was giving was that I was dividing this polynomial by 2 different linear divisors, but the remainders had to be the same. So I equated the remainders, and I realized that I could use the remainder theorem to determine each of those remainders. In this case here, p at 1. In this case here, p at -3. Okay, that's it for this one.